Hello. So this is section 4.3, the last section of chapter 4, quantitative relationships from the balanced equation. This section is about exploring the relationship between the mole and mass relationships of substances involved in balanced equations. So in this equation, we can see is not balanced. Right away, there's 2 hydrogens and 3 hydrogens. So let's tally the elements. So there's 2 nitrogens and 2 hydrogens on the reactant side, but there's 1 nitrogen and 3 hydrogens on the product side. So let's try 2 ammonias, and that doubles and makes 2 nitrogens and 6 hydrogens. So the nitrogens are balanced, but we need to adjust the hydrogens. Let's try 3, and that makes 6. So now everything is balanced. So this particular equation could be referring to a number of things with these numbers. The coefficients 3, 1, and 2 could mean that it's 3 molecules of each, 3 hydrogen gas molecules, and 1 nitrogen gas molecule yields 2 ammonia gas molecules. Or it could be talking about they're referring to the number of the molecules. It could be that there's 3 moles of hydrogen gas reacting with 1 mole of nitrogen gas, yielding 2 moles of nitrogen gas, ammonia gas. Or it could be referring to molar values. So and in grams. So 6.03 grams. If you add up the molar masses of hydrogen and for 3, each hydrogen gas molecule would be 2.016 and multiply that by 3 and it's 6.03. And the molar mass of nitrogen gas would be, each one of the nitrogens is 14 grams. So 2 of them would be 28 grams of nitrogen gas, yields 2 moles of ammonia gas. And if you add up the sum of nitrogen and 2 nitrogens and 6 hydrogens, you'd get 34 grams of ammonia gas. So we could draw them in balloons and say 3 moles of hydrogen gas, a total of 6.03 grams, and 1 mole of nitrogen gas, a total of 28.02 grams, would yield 2 moles of ammonia gas, which would be 34.068 grams for 2 moles. So any of these things could be referred to by the coefficients, the stoichiometry that labels this equation. So that brings us to talking about equivalencies. So the same equation, just to be familiar, talking about something that we're familiar with. The equation below tells us that 3 moles of hydrogen can combine with 1 mole of nitrogen to produce 2 moles of ammonia. So now an equivalency, it sounds like it would be something that's equal, but it's not. It does not mean equal. It does not mean the same as, and it does not mean equal to. But it does mean that something is proportional to, and it uses a symbol with 3 lines. So it's kind of like an equal sign with an extra line on top. So some equivalencies that we could say from this particular equation. It only applies to this, whatever equivalencies you say, it only applies to the equation that you're discussing. So we could say that 3 moles of the hydrogen gas is equivalent to 2 moles of ammonia gas, or 3 moles of hydrogen gas is equivalent to 1 mole of nitrogen gas. Or we could say the 1 mole of nitrogen gas is equivalent to 2 moles of ammonia gas. So any of these things using these ratios from a balanced equation could be equivalencies to each other. So this idea of equivalencies, even though we haven't called it an equivalency, maybe they're things that we use all the time, every day, probably. So for example, if you were following a recipe such as the Toll House chocolate chip cookie recipe. So among lots of other ingredients that it calls for, it does call for 2 eggs and 2 sticks of butter, and the yield is supposed to make 5 dozen cookies. So some equivalencies for that cookie recipe are 2 eggs are equivalent to or is an equivalency to 2 sticks of butter, or 2 eggs is an equivalency to 5 dozen cookies, or 2 sticks of butter is an equivalency to 5 dozen cookies. Now, similarly, if you were looking at the stickers on cars and seeing what their gas mileage is or something, or um, if you know the gas mileage of the car that you all ride in or drive, 1 gallon of gas is going to take you so many miles. So this car is supposed to get 30 miles, an average of 30 miles to the gallon. So if you bought 5 gallons of gas, you would expect to get around 150 miles to be able to go. So another topic that we need to talk about is limiting reactants. So limiting reactants, that term refers to whichever reactant will run out first and cause the production to halt. So whichever one that runs out first. So let's say that, just using the previous examples that we just talked about, if you needed to bake cookies and you had plenty of all the other ingredients, but you check the refrigerator and you only have 1 stick of butter. So if it calls for 2 sticks of butter, the best you can do to make them turn out right is to make half of the recipe. And if a car has only a half a gallon of gas, then you could only get up to a half of however much the gas mileage is. So if it could get 30 miles to the gallon, it could probably get up to 15 miles with a half a gallon. So the limiting reactant is just whichever ingredient will run out first and cause production to stop. So let's do example 4.4 that's on your page 88 in your book. It says a chemist wishes to know how many grams of oxygen it would take to completely burn 75.0 grams of propane fuel, which is C3H8. So we have this equation, propane plus oxygen yields carbon dioxide and water, or water vapor rather. Now, first of all, step one, we need to balance this equation. We've got to balance the equation, and so let's tally the elements on both sides of the equation starting out. So we're starting out with 3 carbons, 8 hydrogens, 2 oxygens on the reactant side, but we only have 1 carbon, 2 hydrogens, and 3 oxygens on the right-hand side. Now notice that there's oxygen in both of these compounds, so we're going to have to pay attention to that. So let's start with the hydrogens because we see over here that there's eight on the left. So to balance that right here, let's try 4 water vapors. Now, if we have that, we're going to have 4 oxygens. So 4 oxygens plus 2 oxygens makes 6 oxygens. So now these oxygens don't match. So the hydrogens look good. The carbons, we know they still don't match up. So we need 3 carbon dioxides to be able to get 3 carbons. But then that's going to give us 6 more oxygens. So that gives us 6 oxygens plus 4 oxygens makes 10 oxygens. So our carbons are balanced, our hydrogens are balanced. Now, if we make, let's balance the carbons. Let's balance the oxygens now. So here is oxygen, and we need a total of 10. So let's put a 5 here, and that balances all of our equation. So there's 1 mole of propane to 5 moles of oxygen gas yields 3 moles of carbon dioxide and 4 moles of water vapor. Okay. So at step 2, we need to convert this 75 grams of propane fuel into moles. So we have 75 grams of propane fuel, and we know what the formula is. So we need to multiply the grams of propane times 1 mole of propane and divide it by its molar weight. So let's look at the periodic chart, and we need to figure out what the mass of carbon is, 12.01. There's 3 of them. So 3 times 12.01 is 36 and 3/100ths. Then there's 8 hydrogens. And if you look at the periodic chart, the molar mass of hydrogen is 1.1 and 8,000th of grams. So that's 8.064. So we add those 2 numbers together, and the digits for significant figures needs to just be the 100ths place because our carbon doesn't have a 1,000ths place right there. So let's drop the thousandths place. So we'll just keep the 44 and 900ths. So 44 and 900ths gram propane is the molar weight of propane. So 75 grams divided by 44.09, our grams are going to cancel out, and it gives us 1.70 moles of propane. So we know how many moles. Now we know how many moles of propane that we've got reacting. To fully burn it, we're going to need the equivalency of oxygen. So 1 mole of propane is the equivalency of 5 moles of oxygen gas. So we need to multiply that by 5. 1.70 times 5 is 8.50 moles of oxygen gas. Now we've run out of room, so I'm going to recopy this on the next slide. So 8.50 moles of oxygen gas. Now Step 4, we need to look back at the problem and read what the question is. We need to make sure that we've answered the problem and that the answer is in the requested units. It says how many grams of oxygen. Our units up here is how many moles of oxygen. So we've got to convert this to grams, but that's easy. So 8.50 moles of oxygen. This time we put the moles on the bottom because we want our moles to cancel out, mole oxygen and mole oxygen. So 1 mole of oxygen gas is 32.00 grams. Each oxygen on the periodic chart, its mass is 16.00 grams per mole. So 8.50 moles, let's cancel the moles out. So 8.50 times 32.00 grams is 272 grams of oxygen gas. So that's how much oxygen gas, how many grams of oxygen gas it would take to completely burn 75 grams of propane. Now, in the future, we did this in a lot of little steps, but in the future, we need to get to where we can multiply it in one big string and go from the numbers that they give us and convert it all the way across to the correct units that they want us to have. So to combine those steps, we start out with the 75.0 grams of propane and we multiply it by the molar mass of the propane. So the grams cancel out and that turns it into moles of propane. Then we want the moles to cancel out. We use the equivalency right here. We're multiplied by the equivalency of oxygen and propane. So that multiplies it by 5. Then we have our moles of oxygen to cancel out when we multiply by the molar mass of the oxygen. And it gives us our units that we want, grams of oxygen gas. So it's kind of fun to cross out. I've got the red set crossed out, and then the yellow set crossed out, and the green set crossed out. And then you just multiply all the numerators across, and then you divide by all the denominators, and you get 272 grams. So, all right, and so that brings us to the end of chapter 4. I've got a Jeopardy review for chapters 3 and 4, and the next thing you'll be doing is your test 2, the second test. So this is a Jeopardy game that I've done in the past. Here are the 5 different categories, and I just took a screenshot of each of the questions. And so I'm going to let you pause the video and give yourself time to see if you can write down the answer. And then I'm going to click to the next slide and it's going to have the answers to these questions. And then I've got the next 4 questions and then the next slide will have those answers. So you just pause the video as you need to. And then when you're ready, click it and it'll go to the next page and show your answers. So for the binary molecular compounds, make sure you look at those prefixes and use that for whatever number of each one of the elements. All right, so that finishes the review. And if you have any questions or don't understand anything, just any certain problem, let me know. And you should have your test 2 finished and bring it on Friday. See you later.